Introducing systems as simple as sorting waste on site and making sure that that waste doesn't go to a landfill but gets reused are very smart solutions that can be easily implemented both here in Hong Kong and in China. Also very much looking at preservation. So this is a project that we did in Hangzhou, just outside Hangzhou, where they specifically looked at degraded sites inside their site area where maybe there was a forest fire or maybe there was a heavy flood that year and a lot of trees got damaged. That's where they decided to put their houses. And interestingly enough, they built their architectural form around the natural landscape. So it's very common to see in this development trees just going straight through the roof of a house and incorporated into the design. Water obviously is a huge part of the green building certification system. This is that same project, and it's a very interesting and innovative solutions that they put together. This is a natural pond that existed. It's in a valley. They drained it and put a pumping system underneath it. And what they've been able to do is an entirely closed-loop water system where you have rainfall, and that rainfall goes into two places. It either goes straight into the retention pond by trickling down from the valley, or it trickles down into the natural groundwater, which is then used on site for drinking, and then also your sinks and your showers. From the retention pond, that water is then pumped for irrigation, for landscaping. It's used as fire suppression system, but then it's also used as wastewater for all the toilets and the urinals. So whether the water is being flushed from your toilet and your urinal, or whether you're drinking it and then eventually it makes it to your toilet and your urinal, it gets then pumped into an on-site wastewater treatment system, which purifies the water to very high level, and then pumps it back into the retention pond for use on site. And the sludge is used for fertilizer. So through evapotranspiration, you can see that it's a completely closed loop water cycle where no additional water, very little additional water is needed for the site to really, for the hotel to operate. Energy, in terms of point score and in terms of importance, is by far the largest section in the LEED system. And what my company specializes in is energy simulations and computer simulations. This is looking at ventilation flows on inside buildings and outside buildings to see how we can maximize passive design. So in other words, to use natural ventilation instead of using air conditioning units to save energy. Also looking at daylight and how that works throughout the site. Looking at how different facades can impact light infusion inside floor plans of buildings and how that in return can save on electricity. And then doing whole building energy modeling from the very early stages so that we can maximize mechanical and electrical systems to really improve the amount of energy saving that can be achieved. And the reason why I'm telling you this is because all of these ideas are all what we call passive design ideas. And if there's anything that you take away from my presentation tonight, it's this slide. Most people, when they think of green buildings, they think of, wow, that's an amazing solar panel that they have on the roof, or that's an incredible high-tech system that, I don't know if you saw the building in Korea that's invisible. They've made an invisible building in Korea. Well, really, the most fascinating thing about green design is the design itself. So a building should operate without any mechanical electrical systems. And when we consider this inverted energy pyramid, the top of the pyramid, the most energy efficiency that you can achieve is through the maximization of the design. So having strong thermal mass in your materials that automatically reduce the need to have air conditioning and heating. Orienting your building in a smart way so that solar gain doesn't cause you to use more heating and air conditioning. And when you've reached your maximum level of efficiency in your design, or if you cannot spend your extra dollar, if your marginal cost for that next unit of improvement is too much, then you start looking at the next level of the pyramid, which are your mechanical and electrical systems. And then you maximize those until you reach a higher limit, until your marginal cost is too much. Then you start looking at other things like on-site renewable energy, using biomass, using solar hot water, using photovoltaic panels to generate electricity. And when that cost impact is maximized, then you can start looking at things like offsetting. So buying carbon credits to offset your overall emission. This is your true path to a net zero carbon building design. The last part that I'll talk about are materials. There's a strong focus in using sound and healthy materials. So using reused or reclaimed material like old barn windows, renewable materials like bamboo and cork and linoleum, using recycled materials, both from a structural point of view and also interior decorational. Use of natural material. This is a beautiful building material that is really taking off in China. It was actually used in the Great Wall as part of the construction on the western part of the Great Wall. It's called a rammed earth structure, where they're really just compressing mud and 10% concrete to create this beautiful structural wall with incredibly high thermal mass that almost completely eliminates the need for heating and cooling. And you can see they've inserted a layer of insulation as well. But then looking at it from the purely internal point of view, making sure that the rest of the materials that you put on in your project, so your carpeting, your cladding, have no VOCs, no volatile organic compounds that could reduce the health and well-being of occupants. And then this is something that the Hong Kong beam system looks at very closely, is how you manufacture your materials, how you put together your building in a more intelligent way. So this is a picture of another one of the types of the villas that was on that resort. And what they used is prefabrication. So the components of this villa were actually made in a factory in Dalian and then shipped to the site. And this not only reduces a lot of waste on the site, but it actually reduces a lot of transportation costs and a lot of overall embodied energy reduction that can happen through economies of scale of making building components in a factory rather than making them on site. And also, the speed of construction increases. So this is the villa at the very basic level. They only have, right now, that's the bottom floor, and they only have the foundations, which is a small steel structure and a small cement base. And then over the course of only 5 days, they put together the entire villa. And this is what it looks like now. So I think they built this entire row in about a month. It's pretty incredible. And because they were in such a sensitive location in terms of its natural environment, as you can see, they really were able to minimize waste. And they completely eliminated the need to cut down any trees for construction. And then last but definitely not least, what these green buildings are all about is how people use them. You can build and design the greenest building in the world, but at the end of the day, if your users are not educated, then it's completely useless. So what the certification systems do is they look closely at how you educate your users and how you educate your local community. So this project in particular hired local villagers to work on the property, taught them English, helped them with gaining some actual life skills. And we did an economic evaluation of this village where this project is compared to the surrounding villages, and their economic well-being is much, much greater than everything else that we found around. And we also incorporated local schools for environmental education programs. So it's spreading positive messages throughout the community. And that's it.